Okay, so this lesson we are going to look at solving an equation, exponential equations with the same base. So that will be our key for today. So let's just start off with diving into some questions here. So to start with, we need to make sure that both exponents have the same base. So in our first question, we're going to keep the 4 to the power of x plus 2. But the 64, we're going to replace that with 4 to the exponent of 3. So now what I have is I have the same base. When you have the same base on the left and the right-hand side of your equation, and you're not multiplying or dividing by any other question, so pretty much the left side and the right side generally look the same except for the exponents, we can cross out the bases. And now we just solve for the exponent. So we have x plus 2 equals 3x. I'm going to solve for x. I'm going to bring that x over, so I'll subtract it. 3 minus x, of course, is 2x. And then I'll divide the 2, and I end up with x equals 1. Again, we've talked about in the last lesson how it's so important that you take the time to double check your work. So you could double check your work by substituting 1 into the equation and making sure that the left side balances the right side. You could also double check your work by graphing both sides. So put this into y1, the other side into y2, find the intersection point. So again, double check your work. All right, so we're moving on to the next question. So we need both the 4 and the 8 to have the same base. So I know 2 to the power of 2 is 4, and 2 to the power of 3 is 8. So I'm going to replace the 4 with 2 to the exponent of 2. And I'm going to replace the 8 with 2 to the exponent of 3. Now once again, the left side and the right side look the same. So I'm going to cross out the bases and solve for the exponents. 2 times 2x is 4x. Here I'll distribute this 3, so 3 times 2x is 6x. 3 times negative 3 is negative 9. So from here I'll collect like terms. So I'm going to subtract this 6x over. 4x minus 6x is negative 2x. And then I'll divide the 2 over, and I end up with positive 9 over 2. All right, solve an exponential equation using radicals, involving radicals. So you're going to start the same way. We want both of these to have the same base. Remember, with radicals, we can write our radicals with fractional exponents. So root 3 is the same as 3 to the power of 1/2. With a square root, the index of your square root is actually 2. We just don't write that 2 there. So remember, with radical exponents, when you're writing as a fractional exponent, your index is always the denominator of your fraction in that fractional exponent. Okay, so now I have 9, which is the same as 3 to the power of 2, and my index is 3 in this case because it's a cube root, so the denominator in my fractional exponent will be 3. So now the left side and the right side look the same, so I can cancel out those bases and then just solve for the exponents. 1/2 times x is 1/2 x. 1/2 times negative 1 is negative 1/2, and it equals 2 over 3. All right, I'm going to add that 1/2 to the other side. 2 over 3 plus 1/2, and again, you can do this on your calculator. Feel free to use that calculator. So if we go 2 over 3 plus that 1/2 math fraction, we end up with 7 over 6. Okay, and then from here, I'll just divide this 1/2 over. So now I'm going to take 7 over 6 and divide by 1/2. And I should end up with 7 over 3 as my final answer. And again, you can definitely double check this by either substituting it back in or graphing. All right, so we're going to look at the next question here. It says solve the following. Start by writing them as the same base. So 27, I know is the same as 3 to the power of 3. 81 is the same as 3 to the power of 4. Okay, so now I'm going to go ahead, distribute that 3. So I end up with 3x minus 6. And my issue here is that I have the 3 to the exponent of 4 on my denominator. So what I want to do is I want to move that to the numerator. All right, so in order to do that, I'm going to write this as 3 to the exponent of negative 4, just like that, because I want it to look the same on the left and the right. Once it looks the same, now I can cancel the bases out. All right, and then I'm just going to solve for those exponents. And I distributed that negative 4. Now I'll collect like terms. So I'm going to add 4x over to the left-hand side here. And I end up with 7x minus 6 equals negative 12. I'm going to go ahead and add that 6 to the right side. And I end up with negative 6. And then I'll just divide the 7. And I end up with x equals negative 6 over 7. All right. So next question, we have a bacterium triples every 6 days. After how many days are there 243 bacteria? So we're going to get into this formula. This is on your formula sheet a little more in the next week or so. Pretty much though, the A is always your initial amount. In other words, it's your y-intercept when you look at a graph. Your B is always the factor that you're exponentially increasing or decreasing by. So if you were exponentially increasing, it would be a number bigger than 1. If you were decreasing, it'd be a fraction. You will never have a negative value in for B when we deal with exponential graphs. Your T is your total time, and the P is the time it takes for B to occur. Okay, so if it takes 3 hours for a bacterium to double, your P would be 3. So it's the time it takes for B to occur. And like I said, we're going to look at this more in the coming weeks. So we have 243 bacteria, so that's our Y value. A bacterium, so that means we start with 1 if it's a bacterium. So A value would be 1. It's tripling, so my B value would be 3. So it triples every 6 days. So that means the P is 6 because that's how long it takes to triple. And I'm looking for my total time that it takes for 243 bacteria. So obviously you could divide this 1 over, but you don't need to. So for this question, we're going to write them as the same base. So I'm going to look, 3 to the power of what gives me 243? Let's try 3 to the power of 4. That didn't work. Let's try 3 to the power of 5. That worked. So 243 is the same as 3 to the power of 5. Now I can cancel those bases, solve for the exponents. I'm going to cross multiply and I end up with 30. So I know there will be 243 bacteria after 30 days. Okay, so we get into some more complicated questions here, but don't fear. So 125 over 216, and then I have 6 over 5. So these look pretty close to the same thing, except for it's almost like they're flipped. So I know 125 is 5 to the power of 3, and 216 is 6 to the power of 3. So I'm going to replace this like so. And then because I want them to look the same so that I can cancel out those bases, what I'm going to do is I'm going to flip this fraction and then raise it to the power of -1. Okay, so now I have the same base, so I can go ahead and cancel those bases out. And then I'm going to multiply. So I have 3 times -x over 4 gives me -3x over 4. And then I can distribute that negative. So -1 times 3x is -3x. -1 times -3 is +3. All right, and then from here, I can do this several different ways. I'm going to actually cross multiply this 4 just to get rid of this fraction. So I'll have to divide times both sides by 4. And then I'll collect like terms. So I'm going to add the 12x over. So -3x plus 12x is 9x equals 12. And then I have to divide that 9, and I end up with 12 over 9 which is the same as 4 over 3. And you might have went a different route. As long as you end up with 4 over 3, then whatever you did was fine. Okay, so now we get into some diploma questions. I want you to pause the video, try the question by yourself, see if you can do it, then press play and see if you did it correctly. This question actually scored very low when it was released on the diploma. Okay, so we're going to start off by just writing everything with the same base. So I know 125 is 5 to the power of 3 over 5 3x minus 4 equals 5 squared x minus 5. Okay, so you can't just cancel all the bases out from here because the left side doesn't look like the right side. The left side's a fraction, the right side's just one term. So what I need to do is use my exponent laws. That's why the last lesson was so important. You need to know those exponent laws. So when we divide two exponents with the same base, we can subtract those exponents. So I'm going to go ahead and distribute this. 3x times x is 3x squared. 3x times 1 is positive 3x. Minus, and I have so many kids make this mistake, put the denominator in brackets or else you will forget to distribute that negative. And that negative applies to every single term in that denominator, not just the first term. So 2 times x is 2x minus 10. Now the left and the right look the same. I can cancel those bases out. And from here, I'm going to distribute that negative and then collect like terms. All right, so this works out nicely. The 3x and the minus 3x cancel out. Okay, I can bring this negative 2x to the left, or the 2x to the left, which makes it negative. I'll bring the negative 10 over, so I'm going to add the 10 over. So I end up with plus 14. All right, so the C value then is 14. All right, next question. The value of x in the exponential equation, so we're looking for x. So this time they're giving us variables, right, instead of numbers, but it's the same thing. We're doing the same thing. So just like the question we looked at a few times ago, hopefully you notice that these are almost the exact same thing except for the base is flipped. So you can flip either one. I'm going to flip the left one or the right one. But if I flip it, I need to add a negative exponent. So I just moved the 3 to the outside and I added the negative because we flipped that exponent. So now I have the same base and I can solve for x now. Distribute that 3x to both terms. And then I'll collect like terms. So I'm going to bring the 3x over. I end up with 5x minus 3 equals negative 12. I will add the 3 over. And I end up with negative 9. And then I'll just divide that 5 and I end up with negative 9 over 5 as my answer. So again, this is an example that you can double check. You can do a lot of double checking on the diploma. So they will give you variables because they don't want you to graph it to solve. However, you can just substitute numbers in for those variables, any number you want. Still graph it. Your intersection point of the left and the right side should still give you the same answer. So again, whenever you can find more than one strategy to find your solution, the more likely that your work is correct. All right, that's it. Try some of these practice questions.